D says use the formula T of n equals A times R to the power of n minus 1 to write an expression which could be used to calculate the value of the investment after 10 years. Simplify it, but don't evaluate it. So T of n would be, what is the value of the investment after the first year? That was this right here. So that's my A value. A is equal to this 5,000 times 1.03. My R is equal to the 1.03. And my N value is 10, the value of the investment after 10 years. So T of 10 would be 5,000 times the 1.03 times the 1.03 to the power of 9. And if I simplified these two, the bases are the same, which means I can add the exponents. I end up with 5,000 times 1.03 to the power of 10. So question E says state the value of the investment after the first year, after the second year, and then after the 10 years. So after the first year, we just take it from what we had above. If I take 5,000 and multiply it by 1.03, what do I get? 5,000. Okay. After 2 years, I would multiply it by 1.03 again. Or I could go 5,000 times 1.03 squared. $5,304.50. And then after the 10 years would be calculating out this expression. 5,000 times 1.03 to the power of 10. And tell me how much money you get. What'd you get, Evan?
$6,719.58.
So in 10 years, I gained just about $2,000 interest, or $1,700 interest. Use the general formula to write an expression that could be used to calculate the value of the investment after n years, and show that this could be written as a power with an exponent of n. So if I look at my general term, T of n equals A. From above, A was 5,000 times 1.03. And then R is 1.03. And then I have to the power of n minus 1. If the bases are the same, and I'm multiplying powers, I can add their exponents. The exponent here is 1. If I go 1 plus n minus 1, what happens to the 1s? Cancel each other out. They're going to equal 0, so I'll be left with n. So I get the equation 5,000 times 1.03 to the power of n. So then part G says, suppose that an investment earns interest of I% per annum. Develop a formula for the amount of the investment after n years, which is the compound interest formula. So T of n is the value of the investment at the end. That's my A. T of 1 is what I started off with. That's my principal, my P amount. And then I have my interest, which I'm going to take and I'm going to add it to 1. Or I guess, because I is given as a percentage, I have to divide it by 100 first. Like that. So I have to take my interest, convert it to a decimal, and then it would be to the power of n, just like what we did in this equation here. So we're going to look at this next year when we look at exponential functions, but this is the formula which comes from a geometric sequence. The big thing with the last two examples is just really understanding what it means for the first term in the context of a problem, because sometimes the first term is not what was given to you in the question. So in the previous question with the balances, depending how you look at it, the first balance is not necessarily the 20, or the 15th term does not necessarily represent the 15th balance. Did I give you any questions from this yesterday? Just question 1? Okay. So then 2, 4, 8, and then 17, 19, and 20.